There is something happening inside your home right now, in the dark, in every room, behind every wall socket. It is happening while you sleep. It is happening while you're at work. It is happening on vacation, while you're sitting at the dinner table, while you're reading this. Your house is consuming electricity, not because you are using anything, not because a single light is on or a single appliance is running, but because every device you own, every television, every phone charger, every game console, every coffee maker with its tiny glowing clock, is sipping power from the grid, invisibly, silently, without your permission, all day long, every single day of the year. This is called phantom load. And it is costing the average American household roughly $165 every single year. For some families, it runs as high as $440 annually. Across the United States as a whole, it drains $19 billion worth of electricity annually, the equivalent output of 50 large power plants, all generating electricity to power devices that are technically turned off. The solution requires nothing but something you probably already own. It costs $0. It takes about 20 minutes to set up across your whole home. And once you do it, it runs silently and permanently every single day, cutting between 15 and 23% off your monthly electricity consumption. No contractor, no permits, no smart devices, no subscriptions, just a switch, the oldest electrical component ever invented. But here's the question that should make you genuinely angry. The Lawrence Berkeley National Laboratory identified this problem in 1997. The United States Department of Energy confirmed it publicly in 2008. The Natural Resources Defense Council published a landmark study in 2015 analyzing 70,000 homes and found that phantom load accounts for nearly 23% of total household electricity consumption. And your utility company, who reads your meter every single month and knows your usage patterns down to the kilowatt hour, has never once mentioned it to you. Not in an email, not on a bill, not in any of those glossy annual energy tips they mail out each summer recommending smart thermostats and LED bulbs. Never. That silence is not an accident. That silence is a business model. This is the story of phantom load, how it was built into your home by design, who benefits from your not knowing what the science actually says, and exactly what to do tonight, for free, to take that money back. The year is 1955. Eugene Pauly, an engineer at Zenith Radio Corporation, points a handheld device at a television set in a demonstration room in Chicago and changes the channel without getting up from his chair. The crowd watches in silence. Then they erupt. Pauly has just introduced the world's first practical wireless television remote control, a device he called the Flashmatic. It worked by shining a beam of light at a photoelectric cell mounted on the corner of the TV screen. You aimed it like a flashlight. You pulled a trigger. The channel changed. It was magic. It was also the beginning of something nobody fully understood yet. Because to receive a wireless signal, the device on the other end must always be listening. It cannot be truly off. It must be partly on, alert, waiting, drawing power, and perpetuity. The moment the remote control became standard equipment, every television set in America became an electricity consumer that never fully stopped consuming. And in the decades that followed, as remote controls spread from televisions to VCRs in the 1980s, to cable boxes and CD players and stereo receivers, to every device that could be turned on from across a room, the always-on architecture spread with them invisibly stitched into the design of every product in every box, on every shelf, in every home. By the late 1980s, 2/3 of American households had at least one remote-controlled device. By the mid-1990s, the number of electronics in a typical home had tripled. Each one sat in standby mode. Each one drew power constantly. Each one registered on the utility meter, turning quietly outside your house, adding fractions of cents to your bill around the clock, 365 days a year. Alan Meyer, a staff scientist at the Lawrence Berkeley National Laboratory in California, was one of the first researchers to take the full scope of this problem seriously. In the mid-1990s, Meyer and his team began measuring something they called leaking electricity, power consumed by household devices when they were not performing their primary function. What they found stunned them. A television in standby mode could draw anywhere from 1 to 15 watts depending on its age and design. A VCR, with its clock blinking, drew between 5 and 20 watts. A cable box drew up to 30 watts all night, every night, whether or not anyone was home. A desktop computer left in sleep mode consumed 15 to 45 watts. These numbers sound small in isolation. Multiply them by the 65 devices the average household had plugged in by the late 1990s, and suddenly you're talking about 100, 150, sometimes 200 watts of constant background draw, running 24 hours a day, 7 days a week for the entire year. Meyer published his initial findings in 1997 under the clinical title Standby Power Consumption in United States Residences. The estimate was that standby power alone accounted for approximately 5% of total residential electricity consumption in America. By the time the next study was published, that number had doubled to 10%. In 1999, the International Energy Agency launched what became known as the 1 Watt Initiative, a global coordination effort to pressure electronics manufacturers into designing devices that consumed no more than 1 watt of power in standby mode. Japan moved first. Australia and South Korea followed. In 2001, President George W. Bush signed an executive order mandating that all federal agencies purchase only devices that drew 1 watt or less in standby mode. The European Union codified it into regulation in 2010. None of this was ever explained to you on your electricity bill. The IEA's own documents from that period describe standby losses as representing a significant fraction of total world electricity use. The phrase significant fraction of total world electricity use is not a niche finding published in an obscure academic journal. It is a conclusion reached by the international body that coordinates energy policy for 38 of the world's largest economies. They knew, governments knew, utilities knew. Electronics manufacturers knew because they were the ones building the standby circuits into every device they sold. And not one of them saw fit to put a single sentence about it on your monthly bill. The reason is not complicated. Your utility company sells you electricity. Every kilowatt hour you consume generates revenue. A utility's business model is built on the assumption of a certain level of consumption. Phantom load is not a bug in that model, it is a feature. It guarantees a floor of electricity demand that no behavioral change, no conservation effort, and no conscious decision on your part can eliminate, unless you know it is there. The electronics industry had its own reasons for maintaining the status quo. By the 1990s, the competitive battlefield in consumer electronics was speed, which television could turn on faster, which cable box could respond to a remote click more instantly. The answer to that question was always more standby power. Engineers were not designing products to be efficient at rest. They were designing them to perform on startup, and the energy consumed in between was treated as an irrelevant rounding error. The consumer paid that error every month without knowing it was there. The NRDC study published in 2015 remains the most comprehensive analysis of phantom load ever conducted on a residential scale. Researchers at the Natural Resources Defense Council partnered with Home Energy Analytics and Stanford University, a sustainable systems lab, to examine data from 70 000 homes using utility smart meters combined with in-person energy audits at a sample of 10 homes. What they found reset every prior estimate. The average home in their study had 65 devices plugged in at any given time. Of those, roughly 2/3 drew more than 1 watt of power in idle mode. The total always-on background load averaged 164 watts per home. The equivalent of running 234 cups of coffee is worth of electricity through a machine that is not making any coffee, every day, all day, without pause. In practical terms, always-on devices represented nearly 23% of total household electricity consumption across the 70,000 homes studied. At the national average electricity rate, that translates to approximately 165 per household per year. In electricity, paid for devices that are not being used. Under some utilities' top-tier pricing structures, the number climbs to $440 annually. The report identified the worst offenders in clear terms. A water recirculation pump left always on could cost up to $93 a year. A desktop computer in sleep mode, up to $49. A television in standby, up to $38. A cable set-top box that records programs around the clock, up to $30. An audio receiver sitting idle, up to $22. A printer plugged in but never printing, up to $11. Add those numbers together for a single household, and you are approaching $250 annually. And that is only for the 7 most common high-drain devices. The remaining 58 plugged-in items are still contributing. The NRDC researchers made a calculation that should be read in every home in America. If all U.S. households reduced their phantom load to the level already achieved by the most efficient 25% of homes in the study, not some futuristic benchmark, but a level that ordinary households are already reaching through basic awareness, it would save $8 billion in annual electricity bills, avoid 64 billion kilowatt hours of electricity per year, and eliminate 44 million metric tons of carbon dioxide emissions. No technology investment required, no policy change required, no smart grid, no solar panels, no new appliances. Just the elimination of waste that is already happening in the most energy-conscious quarter of American homes. The technology to make this happen costs nothing if you already own a power strip. It costs between $10 and $15 if you need to buy one. Here's exactly what phantom load looks like in your home, room by room, and here's exactly how to eliminate it tonight. In your living room, the television, the cable or satellite box, the streaming device, the soundbar, and the gaming console are almost certainly all drawing power simultaneously, right now, while none of them are being used. The entertainment system cluster is the single largest phantom load source in most homes. A switched power strip, one with a rocker switch on the side, costs between $10 and $15 at any hardware store. Plug every device in that cluster into one strip. One switch at the wall kills the load completely when the system is not in use. A single click at night eliminates what could be $75 to $100 in annual phantom costs from that one cluster alone. In every bedroom with a television, the same principle applies. Guest room televisions are among the worst offenders in the NRDC study. They draw standby power continuously for months at a time between uses. In your home office, a desktop computer, monitor, printer, external hard drives, and a router each draw idle power around the clock. The router is the one device that genuinely needs to stay on for connectivity, but everything else attached to a desk can be managed by a single switched strip. In the kitchen, the coffee maker with its programmable clock, the microwave with its digital display, the toaster oven with its warming element, none of these need to be on between uses. The clocks built into kitchen appliances collectively waste enough electricity in a year to be measurable on your bill. In the garage, older chest freezers and second refrigerators are among the highest phantom load sources identified by researchers, some costing over $100 per year while storing items that are rarely accessed. The simple act of going room to room with a switched power strip and a commitment to cutting power to clusters of idle devices can reduce household electricity consumption by anywhere from 10 to 23%, depending on how many always-on devices your home contains. At the national average electricity rate of roughly 17 cents per kilowatt hour, and the national average monthly bill of $163, that reduction translates to between $16 and $38 per month in savings. Over 12 months, that is between $192 and $456 returned to your household every year, without a single dollar invested beyond a power strip you may already own. One additional step costs nothing and requires no purchase at all. Walk through your home and physically unplug devices that are genuinely not used between sessions. Phone chargers when no phone is charging, laptop chargers when the laptop is full, the television in the guest room between guests, printers between print jobs. Every watt of continuous standby draw you eliminate permanently saves roughly 8 to 9 kilowatt hours of electricity per year. In a home with a dozen such devices, that is 100 to 120 kilowatt hours annually, close to $20 at average rates, recovered through the act of pulling a plug out of a wall. The Department of Energy put it plainly in 2008, the same year they confirmed standby power as a documented household issue. Phantom loads can be avoided by unplugging the appliance or using a power strip and using the switch on the power strip to cut all power. That is the complete instruction set. 12 words. The solution to $19 billion in annual national electricity waste is 12 words long, and it has been sitting in government documents for nearly 2 decades. The electricity your home wastes in standby is not a secret held by one company or protected by one patent. It is the accumulated result of decades of design decisions made by an electronics industry that had no commercial incentive to prioritize idle efficiency, combined with a utility industry that has no financial interest in reducing your consumption. The researchers who measured it did their jobs. The government agencies that documented it did their jobs. The science is not disputed. The data is published and freely available to anyone who looks for it. What has never happened is anyone making sure you knew about it in a way that was impossible to ignore. Not on the bill you open every month, not in the tip sheet your utility mails each summer, not in a single piece of communication from any company whose revenue depends on the electricity flowing through those idle circuits. Now you know. You know the number, $165 to $440 every year per household. You know the history, a problem identified in 1997, confirmed in 2008, quantified precisely in 2015, and left sitting in reports that most people will never read. You know the solution, a power strip, a switch, 20 minutes, $0. And you know what happens when you share this with someone else who did not know. That number stops applying to them the moment they do. If this changed how you see that electricity bill, the one sitting somewhere in your house right now, share it. Every person who finds out is one less person funding a meter that is running when nothing is running.